Welcome back, people who are now here. So I'm sure you are pumped up, caffeinated, and eager for our next speaker. So he's a CEO and co-founder of Web3 security company Credshields.com. He's the ex-security analyst come triager for HackerOne. While we are moving towards Web3, let's put our hands together and welcome Shashank to talk about this decentralized ecosystem and its need for security.
Hello everyone, about me, I'm Shashank. I co-founded this company called Credshields, and it's a Web3 security company, and we are building a product called Solidity Scan. So you can, it's like if you know about Web2 security something, then you can say it's like Solidity Scan is something like, Akinetics or Nessus for smart contracts. So you just upload your smart contracts and it will find vulnerabilities in it. So that's what me and my team are doing. Apart from that, previously I was, before starting this company, I was a security analyst for HackerOne. And previous to that, I was a security analyst for Deriv, which is a Malaysian-based trading platform. And before that, I was into bug bounty. So I was among the earliest bug bounty hunters. Like I started in 2012 and did bug bounty for a very long time. I was a part of Cobalt team as well and HackerOne pen test. So this is my background, and from past 2 years, I moved into Web3 security, doing all research, and building this product. So about this talk, what I'm going to say is since we have a very short time, so I'm going to explain very simple things, but they are they have huge impact, and they are very common bugs. And so the problem with Web3 is if I directly jump into vulnerabilities, you're not going to understand many things. So for the first 15 minutes, I would say is just focus on what I'm saying, because that's the basic building blocks, how smart contract works. And then we'll talk about vulnerabilities. And that is essential. So that's why I'm stressing that it's like the initial 15 minutes, bear with me. It will be more about how Solidity works, how smart contract works, how blockchain works. And then we'll jump into vulnerabilities. So what is blockchain? So blockchain is a digitally distributed, decentralized public ledger. So let me explain you in very simple terms how blockchain works. So suppose there is person A, person B, and person C. Okay. Now person A has 100 rupees, 100 INR, and so what person A does is he transfers 50 rupees to person B. And person B transfers 20 rupees to person C. So if we do the calculation, now person A has 50 rupees, person B has 30 rupees, and person C has 20 rupees. Now let's talk about the real world scenarios, like how banks work. So A goes to bank, deposits rupees 100, and he has transferred rupees 30 to 50 to B, and then B has transferred rupees 20 to C. So now bank is something where you're trusting them with your money and the ledger. So they maintain the ledger that, now A has 50 rupees and B has 30 and C has 20. So the problem is, many people started, not to trust the banks. And that's where blockchain came in picture. So, banks might freeze your account or might say that, you don't have 50 rupees, but you have 60 rupees or 30 rupees. And that's why this beautiful concept of decentralization came in. So there is no ownership, there is no centralization, there is no middleman. And that's what blockchain is. So I'll explain the same scenario, what happens in a blockchain. So now consider another scenario where A, B, C, all of them, all three of them have 3 ledgers, okay? So, and in every ledger, everyone has mentioned that the first transaction was transacting money from A to B, and then B to C. And now the same copy is with all 3 of them. And so how it works is there is no central authority. So even if A claims that, I have 60 rupees, which he doesn't have, B and C can verify. So this is how, Bitcoin works. So when when you download a node server, when you host your own chain, so how it works is from day one when Bitcoin was started, and till today, right now, what transactions are happening, you download the entire ledger to your system. And that's how decentralization works. Everyone has a copy of transaction 1 to transaction right now in their ledger. And that's how, it's like verification happens. Like if someone tries to claim, like if I have a node server and I try to claim that I have 10 BTCs, but I don't have it, there are numerous people across the world who are running the same ledger can, say that my claim is false. And that's how blockchain works. Now, since we are talking about smart contracts, the reason I talked about Bitcoin was because Bitcoin, it's like the idea of Ethereum was taken from Bitcoin. So, Vitalik, when he, when he created Bitcoin, he was like, Bitcoin is only good for transactions. Why not make it a programmable blockchain? So the codes are actually on the blockchain. So, it's like codes are there for everyone, codes are immutable, and, it's like nobody can change. So it's like, it's kind of decentralized, environment where you can store your codes, your logics, and that is completely transparent and available to the entire world. So that's how, it's like, if you see the point 2, what it says is like Bitcoin is a scripting language, and it is just limited to true and false statements of a transaction, like if a transaction happened or it didn't happen. But blockchain adds additional, additional programmable chains like conditions where when the transaction should happen, what should happen, etc. and etc. And that's how, it's like, that's why, it's like Ethereum is called as a programmable blockchain. And these programs are called smart contracts. So, it's like we are clear with the concepts of smart contracts. Now, it's like I'll explain the basics of Solidity because these are very essential. So, I have a, it's like a piece of code as well with me where I'll try to explain. Yeah. So Solidity programming language is quite similar to any object-oriented programming language. So if you are studying computer science or if you have knowledge about any programming, object-oriented programming language like C, C++, you'll find Solidity very similar to it with a little bit of changes. So I'm going to focus especially on what things are different, it's like, which is related to the Ethereum blockchain. So the first one is the pragma. So pragma, basically, if you see on the first line, so pragma defines that what compiler version we are going to use to compile a contract, and this is very essential because, it's like Solidity has lots of versions, and, the code has to be compiled on the compatible version. So whenever you see that, so how it is read is like pragma Solidity, which is between version 0.7.0 and less than 0.9.0. So this is the first concept. And then you have contracts. So whenever you are writing a contract, the first thing you do is, it's like you define a contract. Like you define a contract like this. It's a very simple concept. Then we have constructors. So what constructor does is, when it just runs once. So it's very important to learn that constructor just runs once. So when you deploy a contract, what it is doing is, it's like it is creating a variable called owner, and it is setting to as message or sender. Okay, this is important. So message or sender, what it does is like it's a global variable. So it automatically states that the person, the address which is interacting, who initiated the transaction, it will automatically set it to as an owner. Then we have functions. I don't think I need to explain functions. They are like general functions. It's like you write any function like a function like update owner. So it's a general thing. Now this is very important. Please, it's like if you don't understand, do question back because this is related to a vulnerability which I'm going to explain later on. So smart contracts have something called modifiers. So how modifiers work is, when you define a function. So you can see there is a function called update owner, which is taking an input as a new address owner. So this function, what it is doing is like it is updating the contract owner, but it has a modifier called only owner. So how this works is like whenever this execution happens, the code will run till here, and it will notice that it has a modifier called only owner. So before executing this part, what it will do is like it will first go to this, the modifier. And the modifier has a require statement, like it has to validate if message or sender is the owner, like someone who is interacting with the contract is an owner or not. And we have seen here that, it's like owner is defined when the contract was deployed. The address which deployed the contract is the owner. So if this statement goes false, then this function will never execute. And if this is true, so what this does is this instructs the compiler to go ahead with all these later code logics. So this is very important. So I can show you a simple example. So how it works. If we compile this, okay. Okay, let me tell you something. So what I'm using right now is called Remix. So it's like if you are trying to pursue into Web3 security, it's a very good tool where you can it's an online IDE where you can deploy your own smart contracts. And what it does is like it gives you they're self-hosted blockchain nodes where you can actually host the code and test out your code. So so how it works is like if you see like if I deploy this code, so I have to mention the compiler version. So as per the code, my compiler version needs to be somewhere between 7 and 9. So I mentioned 0.8.7, so it will compile. And then it's like when we deploy this code, what happens is like this address is the owner because this was the address which interacted with the contract. So this logic confirms that. So now if you see that, if I try to, if I select another account and try to, update the owner, what will happen is like it will throw an error. I hope it is visible. So you will see, the transaction was declined. Just let me make it up. Yeah. So you'll see the transaction was reverted. So why it happened was because there is an only owner modifier which is checking that, it's like if only the deployer can make changes to the new contract. And then, it's like, I'm not discussing about fallback and receive because that's something I'm not going to talk about. So import functions are very simple. It's like in this sample code you can see, it's like when you, just like any other programming language, when you import a module or external dependencies, that's how you do in smart contracts as well. And then, it's like you have inheritance in smart contracts, which is very similar. It's like contract A is B, and then B will, A will inherit the things from B. Then you have comments, and then, it's like variables and events. So what events are in smart contract is that it's kind of a logger. So it logs things on the smart contracts. Okay, so now we'll talk about vulnerabilities. In smart contracts. So one of the most common vulnerabilities in smart contracts are access control related vulnerabilities. And it's like the concept is kind of same, but the logics are very different in smart contracts. Like what you see in Web 2 is, account A can access the data of account B. And it's something quite similar to similar in smart contracts where, if there is an admin functionality which was not supposed to be accessed by normal user, then there is an access control vulnerability. And this one is an example of an actual hack where there was a smart contract called Hospo, and they got hacked because I'll just show you in the browser. Okay, I want to, give you knowledge about few other things. So every contract which is deployed on Ethereum, there is a website called Etherscan, where it's like if you enter the contract address and if you go to the contract option, you'll be able to see their source code. So the best thing about smart contracts are that most of the smart contracts code are public. They just to bring in transparency, what I was talking about, they publish the entire code, like the actual code, so people can check it. That it's like if the code is doing things as it is supposed to. And that's why it's even easier for hackers to hack smart contracts because the code is public. But if you see on the other side, smart contracts are can be audited as well. Like everything is transparent. So this is the way you can you pick up any smart contract and then you can go to Etherscan and then check their code. So if we see about line 1348, so if we go to 1348. Yeah, so if you see this if you will notice, this is a burn function. So what a burn function does in smart contract is it is used to burn tokens. Suppose I create a token called, shashank token, and I made like 1 lakh tokens. And then, it's like you can mint tokens and you can burn tokens. That's a very common terminology in smart contracts. So minting means like I'm increasing the amount of tokens, and burning is I'm reducing the amount of tokens. So if you see here, what's wrong with that? Can anyone guess like what's wrong with this? Yeah. Exactly. So yes, you're correct. So the thing is, if you see, in general programming, like you will see, it's like there is something called functional visibility. So if you see, the function visibility is public. So what public means is, it's like anyone can actually interact with it. And since there is no modifier, so there is no check. So anyone, any individual can actually call that function and burn the tokens. So this was, this was the Hospo hack where, it's like a hacker could burn all their tokens. And I have a very similar example, which we, which we found during our assessment. So what happened was like, I was contacted on Telegram that one of our clients' friend who had this smart contract called Shadowfi, and they got hacked, and they wanted to know like how they got hacked. And I'll just share my experience, like how we figured out the hack happened. And this is good for understanding how vulnerabilities happen in smart contracts. So so the only thing I got was the hacker's transactions. So let's look at the hacker's transactions. So these are the list of hackers' transactions. So the most interesting thing was the fourth one. So if you see, a huge amount of Shadowfi token was actually burned. So how did we guess it was burned? So the common logic for burning a token is that you send it to a null address. So what a null address is, that a null address is a 0 address. So every chain has a null address, which is a 0 address, and that is not controlled by anyone. So nobody has the private keys of 0 address. And so, since like you cannot simply just delete the, delete the tokens in smart contracts. So what they do is like, when they burn, they send it to the 0 address. So if you ever when I'll share my slides, what you can do is like you can actually click to that 0 address, and then you'll see it has like billions of tokens. And nobody has the authority to it, so that's why it is used for burning the tokens. So the first thing what we noticed was a huge amount of token was sent to a null address. It means the token was burned. So something has to be done with the hacker did something with it's like the burn function. So let's see. So if we check the code at line 962, yeah. So yeah, it's quite the same. It's like the burn function was public. But the question is like, how did he manage to steal all the funds? Like, how did he manage to make the money? So let's go back to all the transactions. So now we know that the hacker, what he did was he burned a huge amount of tokens because the burn function was public. Now let's deep dive into the logic. So if you see the first transaction, he deposited wrapped BNB. So BNB is, since this is Binance chain, so he deposits some amount of Binance token. And the next what he did was like he bought almost like 9.5 SDF tokens. So now let's understand this thing, like every token which is there. So mostly how they work is, suppose there are 100,000 tokens. So and if the price is $1 per token, and suddenly if the number of tokens are 1,000, the rate of the price of each token will increase because there is scarcity. So that's what the hacker abused. So what he did was he initially deposited, BNB coin, and then he bought a minute amount of, he spent like $10 or something, and he bought like 10 Shadowfi tokens. Now what he did was he burned majority of the tokens, creating, scarcity of the token. So now his 10 ShadowFi tokens were worth 300,000 US dollars. So what he did was, first he deposited the money, bought a little bit of token, burned rest of the tokens, and then he, because, again, he's exploiting the ShadowFi token, so definitely it's not very useful for him. And since it is available for a very higher price, what he's gonna do is he just, it's like he just buys, he sells all the 10 tokens which he had, like 8.4 plus 0.5. So he sold almost 9 ShadowFi tokens for a price of $300,000 because of the scarcity. And he ran away with the Binance token. So this is one of the classic examples, how people can exploit access control to, to actually completely, it's like drain the entire smart contract. But again, it's like every access control doesn't lead to, it's like stealing of funds. So when you are like actually looking for vulnerabilities in smart contracts, you can, it's like it's not necessary that every time you'll end up with, it's like finding a bug which cause financial damages. Sometimes, it can give an edge to you at, it's like certain functions or something. So this was one of our client, and so what they did was, it's like they had a contract, and where they were, they were selling they're auctioning their tokens. And the auction was only available for certain, whitelisted users. So not everyone could just, go and, it's like buy. So especially for, it's like, malicious addresses, they added a blacklist that certain person cannot perform, it's like cannot participate in the auction. So this is what they have created. Like they have a function called blacklist, and they have a function called remove blacklist. So again, if you see, there is a missing access control. So they forgot to add actually the modifiers. So anyone could call the function. So if I get blacklisted, what I can do is simply I can call the remove from blacklist and pass my address, and then I'm again, it's like I'm not blacklisted anymore. So this is another kind of vulnerability. Yeah. So the second bug, which, OK, before moving to the second bug, do you have any questions? Because I wanted to make this more interactive. So I kept the slides very less, and I wanted to have like more questions to understand like what, it's like if you have any questions. So do you have any questions about access control vulnerability or something? Like anyone? No? Yeah. Modifier. Yeah, I explained the modifiers. So basically how modifiers work is, it's like when there is a function which is, so OK, for everyone, so the question was like how modifiers work. So as I explained, it's like in previous slide. So how it works is, OK, actually I can show you a nice example. So see, I showed you, it's like how it works is like when you call a function which has a modifier. So what will happen is before executing these code, it will first check with the modifier. So the modifier function states that the require function states that the message or sender should be the owner. So not anyone, any random, it's like address can actually, update the owner. They have to be, they have to be the owner to update the new owner. So let's, let me just compile the code for you. So I already showed you, like, if there is an only owner thing, you cannot update the address. But what if I delete this? What happens if I delete this? So this is the address which is supposed to be the owner. So if we deploy this again, okay, it is deployed. So as per the, as per the rule, this is the owner. Now I'm changing an account. I'm calling the contract with another user, and I'm trying to make myself admin. Okay, it didn't do work. One second. 4B. Okay. So this is the owner. Now I change it back to a new owner. Okay, yeah, this worked. So you see, it's like when I remove the owner, so initially the owner was this address, but next time what I did was, I just used any random address and interacted with the, it's like update owner functionality, and it got updated, it didn't throw any error. Because the thing is, it doesn't have a check for, for the actual owner, which was a deployer. So if you see, the fourth one was the first one which deployed, so the fourth one was supposed to be the owner. But then I was able to, it's like update the contract with the fifth one because there is no modifier to, it's like validate, it's like who is making the transaction. I hope that is clear. Okay. And yeah. So there are bugs related to, integer overflow and underflow. So, it's like you might have heard about overflow bugs in, binary applications, and, it's very, very common. So let's first understand, it's like how overflow and underflows work. And I have a sample code for that. Okay, let's understand this code first. So what it does is like, the first function over, what it is doing is, there is a uint8. So uint8 means that that variable can handle values from 0 to 255. That's 2 to the power, 2 to the power of 8 minus 1. That's the limit. So, it's like you have uint16, uint256, etc., etc. So I'm taking a very, it's like, smaller value so that it's easier to explain. So how it works is like, the overflow, what I'm doing is like, I'm adding 255 plus 2, but it's uint8. So what would be the result? Anyone can answer? Like, what would be the answer for the first one? Anyone? Yes? No, it won't be 2. It would be 1, I guess. Yeah. But you got the concept, I guess. Yeah. So what is happening is like when you define a uint8, what happens is the number cannot, the value can never exceed 255. So in overflow, what it happens is like if you add 2, so it will go to 0 and then 1. So it circles back. It's like what happens in your your motorbikes. When it ends, it will start from 0 again. So that's a, it's like classic example of buffer overflow. And in underflow, what happens is like, since again, if you subtract a minus b, so you are reducing 2 from 1, so it goes back to the highest number. So it won't be minus 1 because obviously it's a uint, it's an unsigned integer, it is always supposed to be positive, and it goes back to the biggest number, which is 255. So smart contracts are vulnerable to, it's like overflow bugs. And I'll show you one classic example of a hack happened because of the, overflow bug. But before that, it's like I'll just compile this code and, just show it to you. Yeah, okay. So it is compiled. I'll deploy the contract. So let's see. So, it's like, oh, it's the old contract. What? 1 second. Yeah. So if you see this one, so it's like when I'm doing an addition of 255 and 2, the result is 1 because 255, then it moves 1 more, so it goes to 0, and then it moves 1 more, and it goes to 1. And if you go for an underflow, what happens is like it goes for the maximum value. So what happens in smart contracts is, it's like if you manage to find a overflow vulnerability, what you can do is suppose, you have 10 tokens, and then, it's like if you know, it's like let me give you another example. So, it's like you have 255 tokens, and then someone sends you one additional token. And if the overflow happens, what happens? Like your address is now your balance is 0. So that's a disaster for a financial application that someone who had the maximum amount of money ended up with being at a 0. So I'll just give you a very classic case, and this one is very funny because this contract was created on 4chan. It's like 4chan is the place where you have all the funds, like some weird things happen. So one guy came up with a smart contract which was purposely made as a Ponzi scheme. So so it was a pyramid scheme. So in pyramid scheme, what happens is like if you refer to someone and then you get some incentives, and then that guy refers to someone else, then the incentives flow in. So you refer, and then you make money. And they just wrote it for fun, and it went viral on the internet, and suddenly everyone was putting money on that. It's like everyone was throwing money into that contract, which was supposed to be, it's like it was supposed to be a Ponzi contract. But the irony was, although it was for fun, but it had a bug. And the bug was that, when they did a subtraction, they did not go for an, overflow, underflow check. So what one hacker did was, he created one account, and he referred to another account. So now the first account can claim money from the second account. So what he did was like he had few tokens in his first account, then second account, and he requested for money which would lead to an underflow. So suppose it's like his second account had 10 tokens, and he requested for 11 tokens. Now his balance is not -1, but the maximum token which the contract was having. So he created 2 accounts, and then manipulated manipulated the balance to assign himself the highest possible balance, which was 2 to the power 256, which is a huge number. And then he sold all the tokens and took away almost like not sure how much money he took. It was a $800,000 hack. So he took away $800,000 worth of Ethereum during that time. So right now that's worth in millions. So this is one of the classic bug. What happened, it's like with the POWH coin hack. If you just Google about it, you'll read that's a very funny story. Okay, so again, that's what I said. Like my talk was supposed to be very short. And if you have any questions, because I know it's like many people want to get into Web3 security, and I wanted to give you like two or three classic bugs, which is very simple to understand. But if you see the impact, it's critical. Like it's like people run away with millions of dollars. So it's like these are some resources, but I'm open for questions. Like if anyone has any questions, you can ask anything related to Web3, and don't feel shy. Like just ask anything. Anyone? Oh, yeah.
Hi. So first of all, great talk. So we have a lot of new compilers like Solidity, not Solidity, Solana, Rust. Yes. So like for the smart contract hacking, like is there any like learning resource, and also how do you approach of doing a audit for those contracts?
You're asking about resources, right?
Resources, and like what's the approach on like?
Yeah, actually, I wanted to like talk about that's a good question. Thank you. I wanted to talk about resources. If you talk about resources for learning smart contract security, what I would suggest is like first learn Solidity, like basics of Solidity. You don't have to be a smart contract developer writing protocols and DAOs or something like. Just basics, and for that, Crypto Zombies is a very good website. So if you go to Crypto Zombies, it's a fun way of learning Solidity, where you are creating zombies using Solidity, and then the zombies are eating each other and it's like creating more zombies. It's a very fun way to learn. So I think you can do that in a week, less than a week. So first learn crypto zombies, and then if you want to learn a bit more advanced one, and especially for reference, I use soliditybyexample.com. It's one of the best, it's like all the concepts of solidity are mentioned there. And even today, it's like, when we want to refer something, we use, solidity by example. Once you're done with that, I would suggest like play that Ethernaut. Ethernaut is a CTF. They have almost like 20 challenges. And you will go through almost all, it's like the challenge will contain, the buffer overflows, bugs related to delegate calls, compiler version, reentrancy, access control. So that's a very great resource. Like, and when you play those challenges, to exploit those, it's like CTF, you have to actually write the, it's like write the exploit smart contracts. Like you have to write the exploits. So it's one of the best way to, it's like learn, smart contract vulnerabilities, about smart contract vulnerabilities. And the other thing is, about
Rust,
your next question, it's like
Rust and like other languages also.
Rust. So see, again, it's like for Rust and Solana-based smart contracts, they have a complete different approach. So what happens in Ethereum chains is that there is a certain governance, and that is applicable to all. It's like you store all the data on the chain, but Solana has a very different approach where they use the renting system. So you actually buy the storage, you rent the storage, and they have it's like completely different class of vulnerabilities. So I mean, explaining that would require another talk. So I won't like go deep in there. And regarding it's like learning about audits and everything. So yes, that's what I say. It's like learn Solidity, then play this Ethernaut challenge. But the best part is it's like to be it's like a good smart contract auditor. You need to have a very good white box auditing approach, because unlike web applications, you just don't it's like make hidden trials or make guesses. You have the contract code with yourself. And the best way, like we as like as an auditing company and my team, what we do is we it's like we go through the entire documentation, we learn their entire business logic, and if you see, it's like there will be a lot of vulnerabilities which will be related to business logic. So once you go through the documentation, they understand how their smart contracts work and what their business logic is doing, it's easier to find vulnerabilities in a smart contract. Any more questions?
Hey Shashank, thanks. I have the query, like as a security auditor, how can we confirm that we have completed all the test cases and the contract is secure? Like
good question. So in this, if you see, yeah, I mentioned that. So SWC registry. So in web application security, you might have heard about OWASP. OWASP has a pretty brilliant checklist.
Yeah.
So it's quite similar. It's like you have something called SW3 registry. I can show you that on the website. So if you see, it's like they have listed a quite good amount of vulnerabilities, and their explanation, and it's like vulnerable codes. So it's like when you're auditing, I mean, I have to agree that this is not the complete list, because there are a lot of things and a lot of research which we found that it's missing here. But as a starter guide, I think if you have completed this entire checklist, you have almost done like more than 70 to 80% of the job. So I think that's the best reference. I mean, it's kind of like you can say OWASP checklist for smart contracts, SW3 registry. It's a very good one.
Thank you.
Thanks, Shashank. I have a question about fuzzing for Solidity contracts, because that's pretty popular as well. And one of the biggest problems with fuzzing is you don't know when to stop fuzzing, right? Like, have you tested every single possible code path? So do you think it's, how useful is fuzzing in Solidity in your opinion? And do you think you can programmatically prove that you have tested every single logic branch in a contract?
Yes, that's a very good question, and I get that quite often. So, it's like, if you talk about fuzzing tools, there is, it's like Consensus wrote a fuzzing tool called, Mythix, and they have an open source version called Mithril. So, I mean, what my belief is that, fuzzing only makes sense when, it's like when you don't have the contract code with you. But especially after the DeFi boom, after 2019, the notion is that if you have a smart contract and if you haven't verified it and if you haven't published the code, nobody's going to interact with you, with your smart contract. And that is one of the reason we chose, like when we were building the product, Solidity Scan, we chose not to go for, fuzzing, because for us it would make no sense, it's like if we get the code, we compile it and then we fuzz it. So, I mean, it's like I don't have a lot of experience in there, but that is the reason I chose not to go with a fuzzer, because, right now it's like any protocol, any company, it's two things are required. First, your smart contract should be verified and published, and second, you have an audit report. So, so everyone is going for a white box audit. And regarding your question, it's like when do we stop fuzzing? So, I mean, it's like we tried to do that, and we had the same issue, and we were also exploring like how Mythics works, and it's like the deep scan can take up to like 1.5 hours sometimes or more. So, I mean, it's like I don't have a very correct answer that when should we stop. Mostly, it's like you can add check patterns where it's going into a recursive loop or something. Then, yeah, we can have a stop on that. But again, my point is, it's like when people are giving you a source code for audit, and it's like finding vulnerabilities would be much easier. Like for our scanner, it just takes 2 to 3 minutes max to it's like list out all the vulnerabilities. And the same thing if you're doing by compiling it and then fuzzing it, I think we are creating problems for ourselves. So that's my answer.
Thank you.
Thank you so much. Okay, so regarding your first question, if you talk about certifications, I don't think it's like I'm the right guy, because in my life I haven't done any certification, even for Web 2. I've been into Web 2 security from past 10 years, but I never did, like, I did certification when I was asked to. But what I would suggest is like, the best way right now is, I don't think any company is providing certifications right now or any good something which I could recommend. So honestly, I don't have an answer for that. What I would say is like, even, it doesn't matter it's Web 2 or Web 3. What I would suggest is like, go ahead for learning things. It's like when you have skill set, I'm pretty sure nobody will ask for your certifications or qualifications. It's like previously I worked with HackerOne. They didn't even ask my, it's like if I was graduated or not. So I think that your skills matter more. And especially when there is less crowd, people are not going to see the certifications or degree. That's my personal opinion. When there is a crowd, like it's like if you talk about developers, like there are lots of developers. So sometimes companies would ask like, are you from this college or from that college? But when there is a scarcity, it's like of talent, then mostly degree is not the barrier, or any certification is not the barrier. Regarding your second question, right now we are not hiring, but I think quarter. 2023, Q1, we are going to expand our team, and will be happening. We'll have more openings for security. It's like security research team. So what our security research team does is like they do audits, and again, whatever knowledge we gain from those audits, we supply it to our product, and that circle makes us, a more productive company. So yes, we might have opening in Q1 or Q2 of next year.
Hello, thanks for the talk.
Hi.
That was really good. I have one basic question, but it still kind of confuses me. There was a weird trend going in the Web3 space. Like there are influencers, there are adult stars, there are famous people are doing this kind of scam. Like they create their own cryptocurrency, and when there comes a lot of investment, they just dilute it. So as the blockchain auditor, how do we come to know that this cryptocurrency is scam or a fake?
Okay, this is exact, problem statement. It was given to us as an auditor. It's like when we were taking feedbacks from different companies. So, I mean, there is no straightforward solution for that. So, it's like what we are trying to do is like we are in our own product as well. What we are trying to do is, apart from finding all the vulnerabilities, we are, it's like what we are trying to do is like we are going to publish. For it's like if you just if you just scan a contract on our platform, it will mention, it will make the code into a very readable form. Like, suppose, just one example which I gave, it's like an admin can change an admin, okay? But an admin can also have functions like they can mint more tokens, they can, it's like they can destroy the contract. There can be a lot of logic related to, it's like authority what an owner has, okay? So, it's like tackling that problem. What we are trying to do is like, we are trying to give, users a very, it's like in a grammatical way, it's like in an English format, or we are trying to say that, okay, the admin here has these many privileges. And based on that, this is a threat score that, it's like this contract can be a rug pull. You might, if I'm right, you're talking about rug pulls where, they launch a token and then they, they dump into the market. So, it's like, for that, as an auditor, what you need to mention in your report is that, the admin has certain privileges and it's not completely decentralized. And suppose if they have no option to revoke ownership. So most of the contracts, if you'll see, they have an admin functionality, but they promise in future that when this contract is stable, what they're going to do is like they will revoke their ownership. So what happens is like there is no admin privileges left anymore. So, but unfortunately, still in smart contracts, when we do say it's decentralized, but if you see 99% of the contracts are actually centralized, they have an owner. And very few companies, I've heard a couple of them who renounce their ownership. So there are other things like there's something called OpenZeppelin has a module called Pausable. So the what it can do is like it can pause a smart contract, like it will pause all the functions, withdrawals, and everything. So the main purpose of the Pausable OpenZeppelin module was that if a smart contract is getting exploited, the admin immediately pauses the smart contract. But then it can also be abused. That it's like if something good is happening, like it's like if the owner is trying to steal the money, he just stops every transaction, he stops all the withdrawals, and then takes away the money. So if you see at like human level perspective, you definitely cannot predict when a scam is going to happen. But yes, you can at least judge that. Okay, if one of the it's like one of the parameters what we use is like we mentioned in the report, if the owner, like the contract owner, is not anonymous, like it is a known personality, they have a verified account, they are an actual person. So most of the auditors, what they do is like they do KYC, like they verify, they publicly mention that okay, the owners are KYC'd, so it's like they are not anonymous people who would just run away with the money. So these are the things, but it's very hard to predict, but you can it's like at least be little bit sure that this is not a rug pull.
Okay, so my second question is to you.
Yeah.
Like in the banking scams, our first step would be to get to the police station, have a 0 FIR, and submit that.
Sorry, can you put the mic? Yeah.
So like in the banking scams, our first step would be to get to the police station, have a 0 FIR, and submit that 0 FIR to the bank. So what would be our first step in the Bitcoin scams or in the Ethereum scams and all the crypto scams?
So there is a company called Chain Analysis, if you have heard about them. So they have done a pretty insane work. So what they have done is like, see, all the transactions are, on a blockchain in Bitcoin, Ethereum, if you say it's anonymous, it is actually not. So, it's like, suppose if, there was a Bitcoin scam and then, what they do is like they actually track the address. So if X address had, the stolen amount of 10 Bitcoin, and if they moved that to another address or deposited somewhere, so what happens is like most of the exchange, like all the popular exchange, as per compliance law, they actually make their wallet address public. That okay, this is the wallet address of Binance or WazirX or whatever. So what happens is like whenever, what Chain Analysis does is like whenever they notice that a transaction from the stolen wallet is made to an exchange to cash out, because ultimately the hacker needs to cash out in real cash, otherwise it's of no use for them. So that's where they catch hold of them. That's one of the method to track transactions and scammers. So that's how most of the hackers have been caught.
So can you repeat the site?
Sorry?
Can you repeat the site that you just said?
Sorry, I didn't get you.
Can you repeat the site that you just said?
It's called Chain Analysis.
Chain Analysis.
Yeah, but that's a complete private company. Like you just simply cannot. So what we are trying to do is like one of our side projects as Credshields. What we are trying to do is like we are creating a wallet tracker system, which will be which will be actually run by the community. So community will report for scammers' address or stolen funds. And right now it's still in development. So what we do is like we will give you a nice graph that from this account, money went to like 10 more accounts, and then you can, it's like mark them, and as per the amount of transaction, which was like from 10 BTC, if 9 went to a different address, you would like to, track it more. So, it's like you can create a line, and then, again, it's, I don't want to go much in detail, but yes, since transactions are on the ledger, it is actually trackable. And once they actually move into a centralized exchange, that's the point where you, it's like catch hold of them.
Thank you, sir.
Thank you. Any more questions?
Hi. Actually, I had a question. You said that it's because it's centralized, you can get hold of them once it reaches like a centralized server. What if they just use a Bitcoin mixture, or what if it's a ledger like Monero or something? Is there anything we can do there?
I mean, in that case, it's pretty difficult to do that. And only thing you can, it's like bother is they make a stupid mistake, or it's like make another transaction, or it's like if the wallet where the money was stolen was, it's like was interacted with someone else. So one of the case scenarios where I heard was, the hacker actually never, withdraw, it's like made any withdrawal, any exchange, but he did a transaction to other guy buying some of his services. And that guy, he tried to withdraw. So the federals caught hold of that guy, and through him, they reached to the hacker. So yeah, if you talk about mixers and the Tornado Cash thing which is happening, it is actually not possible right now to track them. But again, the Tornado Cash, because the Tornado Cash has a very huge volume. But again, it's like if the volume is low or something like that, it's still kind of trackable, but it's hard.
Okay, and I just wanted to confirm. So smart contracts only exist on Ethereum, or do they exist on something like Monero as well?
No, Monero is not a smart contract platform,
Okay.
as far as I know. But it's just a mode of transaction where it's hard to trace. It's like backlink where the transaction went. So Monero is you can say Monero is it's like a Bitcoin which is non-traceable. So
Okay.
that's the reason Monero was banned from all US exchanges.
Yeah, that's it. Thank you.
Hi, Shashank.
Hey, hi. Where are you? Okay, hi.
Thanks for the talk, actually. Hello? Yeah. First of all, thank you for the talk, actually. It was great,
Thank you.
insightful.
Thank you.
And I wanted to know about the flash loans and any interesting findings that happened during your audit related to flash loans.
Yeah, flash loans, it's like mostly happens in, DeFi protocols where, lending and borrowing happens. So, I mean, it's like if you talk about flash loans, it's like mostly when we are doing an audit, we don't conduct a flash loan attack because that is expensive. It's like you actually put in your real $10,000, $20,000 to withdraw a huge amount of money. So we simply check the logic and tell them that this is susceptible to, it's like flash loan attacks. And mostly that happens is because of price manipulations, which was, pretty well covered by Rudra and, it's like Rudra and Arbaz from Unified team. So yes, like again, flash loan attacks and any economical attacks fall in the category of business logic. So if you see the logic is flawed, like they are not doing a due diligence when some contract can get, like some tokens can get inflated value or something like that. So flash loan, it's like that's how flash loan attack works. It's completely business logic.
Thank you, Shashank.
Thank you.